Ever wonder why a rectangle's area is simply width times height or base times height? This video explains it. Even elementary school students know that the area of a rectangle with sides A and B is A times B. However, if you ask them why, almost no one can give a clear answer, not even high school students. It feels obvious, but most people don't know the exact reasoning behind it. Chances are your textbooks and classrooms never explain the why either. So, let's uncover the real reason why the area of a rectangle is just width times height. How do we define area? It all starts by defining the area of a square with side lengths of 1 as 1. In other words, we agree to set the area of a unit square to exactly 1. In the diagram, a rectangle with a width of 3 and a height of 2 contains 6 of these unit squares. Therefore, the area of this rectangle is 6. The number of unit squares inside the rectangle is equal to the product of its width and height, that is, 3 times 2, or 6. Now let's consider a case where the side length is not a whole number, but includes a decimal. For example, suppose the base is 2.5. In this case, look at the two smaller rectangles on the far right. Their width is 0.5, exactly half of 1, and their height is 1. This means each one has an area of 0.5 or half of a unit square. The sum of those two smaller areas is 1. In other words, 0.5 times 2 equals 1. Therefore, the total area of the rectangle is 2.5 times 2, which equals 5. Even if the side lengths are irrational numbers such as square root 2, the area of a rectangle is still calculated the same way, width times height. On the left, we have a square with sides of square root 2. Its area is square root 2 times square root 2, which equals 2. On the right, the rectangle has a width of square root 3 and a height of square root 2. Therefore, its area is square root 3 times square root 2, which is square root 6. Numbers have been extended from natural numbers to rational numbers and irrational numbers. The same pattern of extension applies to the concept of area as well. The principle that the area of a rectangle is width times height applies in exactly the same way to the volume of a rectangular prism. We define the volume of a unit cube, a cube with side length 1, as 1. Therefore, the volume of a rectangular prism is simply width times depth times height. As shown in the figure, the volume of a cube with side length 2 is 2 times 2 times 2, which equals 8. The cube contains 8 unit cubes whose side length is 1. The volume of a rectangular prism with width 3, depth 1, and height 2 is 3 times 1 times 2, which equals 6. The rectangular prism contains 6 unit cubes. The volume of a cube with a side length of the square root of 2 is the square root of 2 times the square root of 2 times the square root of 2, which equals 2 times the square root of 2. The same extension of numbers from natural numbers to rational and irrational numbers also applies to volume. The material discussed earlier is from the book The Why of Mathematics. This book provides clear explanations for many formulas and principles that are left unexplained in most math classes and textbooks. Depending on the reader's needs or interests, even reading just a few topics in this book would make it more than worth its price. This book is primarily for high school students and math teachers. The final few chapters of the book cover some fundamental math for science, engineering, economics, and business majors that are often skipped without explanation, making them useful even for early undergraduates. Refer to the description for a brief table of contents. You can order this book online on Amazon.